Hello everyone, welcome to Mirantis Labs Tech Talks, where we dive into cloud native topics, use cases, tutorials, and many more to educate you all. I'm Avinash Desireddy, Senior Solutions Architect and Developer Advocate here at Mirantis. I'll be your host and speaker today. So here is like the quick agenda of our topic for today. We're going to start with some basic introduction to Kubernetes. I'm not going to like deep dive into it, but just going to briefly touch on it, and then the application and containers. Then we will dive into Kubernetes health checks. They are also referred to as Kubernetes probes. And what are like the different types of probes and mechanisms that are available and how to configure them. And finally, we'll look at a short demo on how Liveness probe, readiness probe, and startup probes can be implemented or are implemented. So now, just starting with Kubernetes. Uh, Kubernetes is a portable, extensible open source platform for managing containerized workloads and services. It facilitates both declarative configuration and automation. It has like a large, rapidly growing ecosystem, and Kubernetes services support and tools are widely available. It is initially developed by Google back in 2014. Now it is part of CNCF, like the Cloud Native Computing Foundation, which is a Linux Foundation project, and it was formed in 2015 to help advance like the container technology, so that it can define a standard and then bring the ecosystem together and aligns the tech industry around its evolution. And some of the features or like the highlights of the orchestrator is on this slide. For example, like it has like this rich ecosystem of plugins for scheduling, storage, networking, or it can manage like it helps to manage applications, like not machines. Like that's one other key differentiator. And so with this introduction on Kubernetes, let's talk about applications. So we use different types of applications in our day-to-day life, either directly or indirectly. And these applications are deployed across a wide range of systems. For example, currently we are using Zoom application to deliver this tech talk and to view this tech talk. And it is using like a lot of backend. It is using like backend API engine, like from Zoom. It has like a front end, like there's a static component to it, like there's a database that is associated with it. So application is like these are like the different types of applications that are available, like some of them. And these applications can run on wide range of environments. Like it can run on a desktop, or it can run in a cluster mode, in a test and QA setting, or in a production setting. The production setting or like the QA setting can be on a public cloud environment or a private data center. So the number of options, or like where these applications can be deployed and how they are deployed, is enormous. And containerize and the technical complexity, the process challenges, and the friction between developers and operations teams in order to coordinate all these changes and to make things happen, it is very complex. And containerization simplifies this with where it eliminates the dependencies, like removes the developer or like minimizes the developer and operation friction between development and operations teams, abstracts like the applications from the underlying infrastructure. So once you package your application into a container, it can run on a desktop, or it can run on a public cloud environment, or in a private data center, uh, with all its dependencies. It is like highly portable, like where it allows us to easily migrate to any cloud or hybrid environments. It provides or it improves security on the existing on how the applications deployed traditionally, because it adds like an additional isolation layer. It is lightweight, which increases the server density like reduces server and licensing costs. So just to like summarize and define like the containers, it is like a standard unit of software like that packages up code and all its dependencies so that applications run quickly and reliably from one computing environment to another. Okay, so with that, like a pod is a core primitive or it's a core primitive in the Kubernetes ecosystem, which represents like a process running in a cluster. Pods encapsulate one or more tightly bound containers, like resources like required to run these containers, uh, and a network interface. Like the network interface is one-to-one mapping to a pod, and then a pod can contain one or more containers. They're always like scheduled on a single node, like regardless of number of containers that are part of that pod. A pod can have one container or 10 containers or any number of containers, but it can run only on one node it can run or it can schedule only on a single node. It provides like a high level abstraction, like making the deployment and management like more flexible. And so with that, like, so this is like once we have like our source code, it's packaged into a container, and then one container or multiple containers are encapsulated in a pod, and then they are executed in Kubernetes. So when we are talking about the application health check or uh, or like the health checks in Kubernetes, applications can become unavailable for a variety of reasons. And where do the applications run? They run inside a container, or they run inside a container. So that's where our key focus is, like how we can make sure our containers are running successfully. And even though if our containers are running successfully, how do we know that it is running reliably? Like for example, like there is no connection loss, or there are no configuration errors, or there are no application errors. So that's the problem of that is solved with the help of uh, Kubernetes probes. What it means by that is like Kubernetes detects the failures and restart pods by default with the help of its scheduler on different components. For example, if a node goes down in the cluster, the pods that are running in that specific node will get rescheduled to other nodes in the cluster, like other nodes in the cluster. If a pod dies because it ran out of memory or for some reason, based on the restart policy that is defined on the pod, it gets restarted automatically. So the default behavior is abstracted to the high level container. If it exits with certain exit codes, that's when Kubernetes or kubelet detects those and then restarts the pods. But what if the application or like the process, the high level process that is inside a container is running successfully, but there was a upstream configuration issue. For example, if one of the services trying to connect to a trying to connect to a database service, and the database is not available, the error simply gets logged into a log file, and then it continuously retries if the connection is available or not. Like on a high level, the container is running, but at the low level, because of the upstream issues, the container, uh, uh, the the application is not running as expected. So these type of issues can be mitigated or can be identified with the help of probes. Uh, just to like reiterate, like it verifies if a container in a pod is healthy and ready to serve traffic. So that's like the goal of like the, that's one of like the key traits of Kubernetes probes. And There are like three different types of probes, like liveliness probe, uh, liveness probe, readiness probe, and startup probe. What liveness probe does is it detects whether a pod is healthy and application is responsive by running a command or making a network request inside the container. Containers that fail if containers like that fail if the checks that fail the checks, they will get restarted all the time. So, and then we'll dive into like each and every probe, and then we'll look at like some snippets and different parameter options that are available. And liveness probe goal is to make sure that the pod is healthy and then the application is responsive uh, all the time. And when it comes to readiness probes, it identifies when a container is able to handle external traffic received from a service. Even though if our container or like if our pod is up, is it ready to accept external traffic? Does it need more time to do all like the sanity checks inside the application, or like to make sure all the upstream connectivity is there? So it might take some time for that to happen. So what readiness probes does is it will control, or tell it will tell the external service like when it can accept the traffic. And the third one is like the startup probes. In startup probes, like provide a way to defer the execution of like liveliness and readiness probes. Like just to keep it in simple terms, even if our container is up, um, like the application inside the container is taking or has like long startup times where it is trying to initialize the database, initialize cache memory, like trying to make connection with some external services. So there is a long startup time that startup times that are involved with like some applications. So so the startup probes will help identify that, and only once the startup probes complete, that's when the container will turn or the container or pod will change its state from pending or a pending state to the created state or like the successful state. Uh, just a quick reminder, if you have any questions, please do use the Q&A panel and post any questions, and I will get through them throughout the session. And if there are any troubles with the network connection or anything, uh, feel free to post them in the chat, and I will take care of them quickly. With that, let's continue. So we just like talked about like three different types of probes here, which is liveness probe, readiness probe, and startup probe. But how we can implement this? Like these can be implemented, or like there are different mechanisms that are available to implement these probes. And like the first one is exec probe. Like what happens here is like the probe runs a command inside a container. The probe is considered like successful only if the command terminates with 0 or with 0 as an exit code. So you can like inject like any type of script like that can run inside this script or a container that inside the container, and based on the response code of that script, uh, the the probe will return the correct status. And then like the second one is like the HTTP probe, like similar to exec probe. What it does is it makes HTTP get request against like the URL in a container. Like the probe is like successful when the containers response has like HTTP status code as 200 or in 200 range or in 300 range. And then like the third probe is TCP probe, where it tries to connect to a TCP port inside a container. Like if the port is open, then the probe is uh, successful. And then like the last one we have is gRPC. In gRPC health checking probe, um, uh, probe like supports like the applications like that are using gRPC. And this particular feature is like the gRPC health check is enabled, or like the feature is enabled from Kubernetes like v1.23. So it was in alpha state, and then it's in progress. Okay, so we looked at like the different probe options, and now like the different parameters like that are available. So like let's say if we have a probe, we cannot we need like some delay on how frequently we need to check, like similar to like how our monitoring tools work, where we have to capture like the monitoring data like every few seconds, or like every 5 minutes, like we aggregate it accordingly. Similarly, in order to make sure our application is healthy, we need to check the status of applications at constant intervals, and we cannot continuously keep checking. Like there should be like some time delay and how many times that it should be checking. So how we can control all of them is with the help of these basic standard parameters, where like the first one is like the initial delay in seconds, where it sets a delay between the time the container starts and then the first probe is executed, and the default value is 0. So as when a container starts, and if we don't specify this value, the probe gets executed immediately, and because like the default is 0 seconds. And then like the period seconds, like which defines like how frequently the probe will be executed after initial delay, and it's defaulted to like 10 seconds. And then like we have like timeout seconds, similar to like let's say if you are executing a script like as part of a probe, and the script is taking too long to execute, then the timeout setting based on like the timeout seconds, like the script will fail, and then it considers as like either a failure or a success. It's like a top threshold for how long the uh, probe should run. And then like the failure threshold, which defines like how many failures are accepted for a container. Like if it is like it is defaulted to 3, if the probe fails like more than 3 times, then the pod or like the container gets restarted in this the pod gets restarted in this instance. And then like the success threshold, this has like the criteria of like reverting an unhealthy container like to a healthy state. Like how many it means like the container must successfully pass this number of consecutive liveliness checks before it seemed to be healthy again. After like let's say we have an instance where our pod failed several times, and now it starts working, then the success threshold controls uh, how many for how many times that it has to be successful in order to mark it as successful. Okay. No, like we have like this code snippet which shows like how a pod can how liveness probe can be configured for a pod with the help of HTTP GET method. So liveliness, like as mentioned, like liveliness probe determines whether or not an application running in a container is in healthy state or not. If the liveliness probe detects an unhealthy state, then Kubernetes kills the container and redeploys it. So here in this case, like in the snippet, we are using HTTP GET probe, where inside the image, or like uh, inside the liveliness container, there is a web server that is running, which is exposing /healthy, and then there is like healthy endpoint, and it is running on port 8080. So what kubelet does is it sends a HTTP GET request on this particular port, like on 8080 on healthy endpoint. If it returns 200 or 300 as response code, then the pod will be successful. So here is like the quick snippet. And then as we go into like the next step, I will be running a quick demo to showcase like the failure state and then the successful state. Similarly, like readiness probes determine whether or not a container is ready to serve requests. Like if the readiness probes returns a failed state, like the Kubernetes like removes the IP address from the container from the endpoint of all services. So services cannot then the Kubernetes like removes the IP address from the container from the endpoint of services. So so the Kubernetes service does not have any information or any endpoint related to the pod. So the traffic will not be sent to the new pod, even though it got created. Since it is not in the ready state, the traffic will not be sent. And like readiness probes is configured similar to the liveness probe, where in this particular snippet we are using exec probe. Like in the liveness probe, we used the HTTP get mechanism, but in this case we are using exec mechanism. What this does is it will verify it will look for the file like /temp/healthy. As soon as it will wait for, the container will wait for the probe will wait for 5 seconds once the container is launched, and after 5 seconds it will verify if this file exists or not. cat/temp healthy. If the file exists, then it is considered the pod is in ready state, and it is ready to accept any requests from the external connections or external endpoints. And like the next one is like the startup probes. Like startup probes, what they do is like they verify whether the application within the container is started or not. Like startup probes like run before any other probe, like unless it finishes successfully, like all other probes are like disabled. So these probes, uh, all of the three probes can be configured on a single pod. Like it's not like you can configure only a startup or only a liveliness or um, only a readiness probe. All three different types of probes are configured according to your application availability requirements or how your application behaves. And uh, like even though like the startup and then liveness probes can run, or like as soon as like the container starts or like the pod starts, like they gets executed. But when there is a startup probe, the both other probes like liveness and then readiness probes, they don't run till the startup probe completes. And it run because what happens is like if startup probe fails, or if the pod is in the starting phase, and then like the liveliness probes gets triggered, or the readiness probes get triggered based on the numbers based on the restart, the failure threshold or like the period seconds. The container gets restarted before the startup probe or before the pod runs. So that's the reason those two other probes are like before paused and deprioritized when startup probe is configured and it's in the execution phase. Now let's look at some of these in action, like how they are configured and then how they behave in action. Okay, I hope you can see my screen. I'm just gonna delete this one. And so by the way, I'm using a tool called Lens, which helps me to visualize like the different workloads that are running in the cluster. And for example, like I'm like running a Mirantis Kubernetes engine on AWS. I have like where the cluster is configured with 3 nodes, like one master and 2 worker nodes, and I'm going to use default namespace to run all these examples or like the demos. So here is like when I filter with all namespaces, like you can see like all the list of pods like running across all the namespaces. So it just like helps me to visualize and then helps me to like navigate easily through all the options. So I'm just gonna increase the font size. Okay. Okay, let's start with Liveness Probe. So here, so this is like a pod specification, and inside the specification, we are seeing like there's a container named Liveness Probe demo, and this is using a busybox image. And when the container starts, what we are doing here is we are creating a file and then just waiting for 30 seconds and then removing that file. So let's see what happens with the live probe. So what live probe does is it verifies if the file exists or not, and if the file exists, then the live probe is successful. That means our application is healthy, and then everything is operational. What if the file does not exist? That means that application is not healthy. There is some problem with the application, even though the container seems to be running. And the initial check will be done like after 5 seconds, like of the container launch, and then this check will be done periodically every 15 seconds. So let's let me execute this YAML file in one of the cluster in the cluster that I've showcased, and then we'll go through the behavior. Okay, I'm just going to quickly create the pod in here. So I just created a probe called Liveness Probe, and as you are saying, it's a container that is running and it is in running state. That's why we see all green. So after 30 seconds, if we just look at the describe or like the list of events, it's easy for me to showcase here. Then if we look at like different events, the pod initially got scheduled, and then it pulled the image, and then it ran successfully. And once after the container, like the container got started like 45 minutes ago, and what happened at 30 seconds ago is the liveliness probe failed, because based on our YAML specification, after 30 seconds, we are removing this particular file from the list. So this is like the command that we are seeing that it is executed internally, and this is the file it checked. So initially on the initial run, it exists, but on the subsequent runs, the health check file does not exist. So what this has to do is it has to restart the container like once it received like 2 failures. So if we run twice, it actually like restarted the container. So if you look, if you're, so the easy way to count like the number of restarts is like we have like this restart option here. So if you are seeing here, the container or this particular pod got restarted 2 times because it failed the health checks probes. Uh, every 30 seconds it is doing it, and because of this failures, it got restarted. And after a few more, and we have one more attempt now, like where it restarted 3 times. So what the so restart is one way to like address like a lot of the problems with the or like some of the problems with the applications, especially like let's say you have a cache issue or like a database connection issue where the connection is initialized during the startup of an application, but if the connection breaks after a certain duration, like typically a lot of applications they don't do a reconnect or reinitializing of connections to the different databases or like to a different components in the system. So like a quick restart will might help address some sort of problems. So here, like since like the containers or like the pod is like restarting from time to time based on our error condition. Similarly, when we implement the health check for a specific application, a developer has to consider all the type of checkings or all the key aspects of the application that needs to be part of the health check. For example, like they can include a script to validate like if database connection is successful or if there are no errors in a uh, certain log trace, things like that can be and uh, implemented and in the Liveness Pro. Okay, now I hope that is clear. Now we can move on to the next one is like the readiness probe. So for readiness probe, like I've like took I've taken a deployment and it is using a simple Nginx service. And what it is using is it is using the HTTP GET, uh, and it is just going to perform a simple HTTP request on port 80, and based on the information that based on the output it receives, it will say if the container is ready or not. And to showcase or like to showcase the service endpoints has the pod IP or not, we are going to create a service of type node port. Let me create this on the cluster and let's see what happens. And just coming back to the liveness probe, because like there were like several restarts on this container. After a certain time, like it gives us like a backup warning because like there are like the container is restarting like several times than expected, like based on based on like the values that we defined, like a thresholds. Okay, now just going to create the readiness probe. I think syntax wise, everything is should be good. Okay, readiness probe created successfully. Okay, it is still processing. Okay, it is in running state. And I just wanted to look at the services, and this is the service that we are going to look at. And here is one of the endpoint. It just failed to update the readiness endpoint because I think like the readiness probe is updating it. So let's verify the events. Let's scale this replica to 2. And we need to have 2 endpoints in here. So like we don't see the endpoint right away. Typically, if we don't have the readiness check, as soon as we create a pod, we will see the additional, not the cluster IP. we'll see the endpoint. So here what it is doing is it's doing a HTTP GET check on port 80, and only once that is available, that's when it is configuring the service endpoint. Okay, so moving on to the next one. So in the startup probe, what we have here is I'm just going to use like the exec probe where the container is going to be sleeping for 300 seconds. And what startup probe is doing is it is checking for a file called /etc foobar, which is not available. And let's see what happens when we run this. Uh, since this particular command verifies if our container successfully started or not. So based on what is specified here, the startup probe will fail continuously, and then our pod will be in the restart loop. Let's create resource and paste the YAML file and click create. Okay, and we have the startup probe here. If we observe it closely, it keeps restarting. It takes some time because our periodic threshold is 10 seconds. So it's going to be, it will wait for 10 seconds. And after 10 seconds, we can see it turns to failure. So currently it is in the starting phase where startup probe failed because at the 10 second at 10 seconds it verified if the file exists or not. It does not exist. So it is going to wait for 10 more seconds, and then it will run this again, and it will fail one more time. So it continuously repeats till it meets the failure threshold. Once it meets the failure threshold, the then the container like stops restarting, or it marks the pod as failure. Okay, we can wait for that to happen. Probably I can just reduce the time to 5 seconds. This is a pod, not a deployment. Okay, let me just change here, periodic seconds 5, and then failures 2. Just going to make it as demo 1. Yeah, we have it here actually. So since after it met the failure threshold, it did a restart of the pod. So same way, like this is going to be doing a quick like sooner. Like it's going to like we're going to see like too many restarts on this container because the failure threshold is small, and then our periodic seconds are small. Okay, I hope this is clear and pretty quick. So we are like seeing like the error messages and then like the respective warnings on this. See on this, like we saw like one restart because it failed on these attempts. You can also like verify all these like on a step-by-step events with the help of kubectl describe command. Describe pod and then provide the pod name, and then it will show you like the like all the list of messages, like how they are being executed. And so just going back to the slides, so that concludes our topic for today, and wanted to thank you everyone for joining me today. I hope this session is helpful to you, and you will be able to configure the probes accordingly based on your application availability requirements easily. One thing I just wanted to like iterate is like health checks, or like the simple health checks that we have seen is just to see if a file exists or not, but we can do much more by adding more scripts where we do like robust checking on different upstream or like downstream connectivities to make sure our application is not just in a running state, but it is operational enough to process user requests. So with that, next week, and thank you so much for everyone for being here uh, and learning and joining us to learn about like different Kubernetes topics. Next week we have not next week, on November 22nd, we have a session on introduction to gRPC and using it in Kubernetes. Feel free to join us. One of our solutions architect is going to talk about like gRPC and how it can be used in Kubernetes in depth, so you can leverage them in your architectures. Thank you so much for joining me today. Have a good rest of your day or like your week. Thank you so much.